my cell phone was laying on the back table. And I had 2 phone calls within 5 minutes. So I've been told, turn your phone off. Okay.
Just you can click this or up or down here.
Okay. I've been around for quite a while, not as long as some here, but when I first, well, let me start. That'd be the best thing. Okay.
It's picking up on 2 different nights.
Yeah, it's not.
Okay, there you go. Just do the arrows or click on the left mouse.
Okay, yeah, I'm real good at this, as you can tell. The site was donated by Max Farash, who was a real estate builder here in Rochester for many years. And he had this just about 17 acres of land, and that's the Farash Center. Okay, that's it. It's almost square, about 950 feet on the side, 17 acres. We're landlocked, but we do have a right-of-way into the site. And this shows all of the buildings that we currently have, even though it was taken quite a few years ago. No, this is Google. I'm sorry, I guess it was. This is a drone view up over the deck a few years ago. This building has been replaced with another small dome, and the walkway has been covered in asphalt. But other than that, I think it's a pretty accurate photograph. From the big dome, this is a photograph of an activity, celebration on the deck. And we were showing off our new zero-turn lawnmower.
Most expensive piece of equipment here.
Pardon?
Most expensive piece of equipment. The most expensive piece of
Oh,
equipment here.
yeah, by far. That'll go like you can't believe when you have it opened up. And we have 2 riding mowers I'll mention in a bit. But up here, you're in the classroom area. This building was built, and I had some of the information on the bottom of the slide, but
It's probably up over here. If you go back, you have the information on the back of the slide.
like I said, I'm real good at this.
No, there's no notes on it. Sorry. It would be down here if there were notes.
Oh, okay. But when I started, what, about 20 years ago, I guess, this building existed. We had a small dome, a different small dome right outside of this building, and the big roll-off up on the hill where the bear was trying to get at Bill. Around the corner, we have a small kitchen area. We usually have a K-cup coffee maker. And we have a microwave. Around the corner, we have a refrigerator, a restroom, and a drinking fountain. This is about half of the library. You couldn't get a picture of the whole thing. And it's been made searchable by John Rhodes. I don't know. I haven't seen or heard from John in a long time. Any news?
John was here last month.
Oh, he was? Oh, good. In the basement, we had a lot of donated lens and mirror grinding equipment that was donated from the Hawkeye plant. And something we never used that had current that we didn't have on site, all the motors and so on. So we finally got rid of all of that. And we have a lounge area. Now, as of now, this the area where the sofa is, has a lot of the lone telescopes that members can borrow for periods of time until they get their own equipment. So that's a nice thing to have. This is a view from below. The Boy Scouts had put in a fire pit that we kept running into with our cars. So it's now back behind us in the woods. This is a dome small dome that replaced the dome that was there originally. For naked eye binocular viewing, which is good for constellation study. That's something I always like to do. Read up on the Greek and Roman mythologies of these constellations, and then come down with a star chart and learn your way around the sky. Meteor showers. We used to have a group, quite a few people come down for the Perseid meteor shower, usually around August the 11th. And I hope we'll be down here this year for it again. You need a night with no moon, they're the best. And we can set up our lawn chairs and so on and get a blanket and just have a nice time, have an IPA or two. For Aurora, if on some occasions you can see northern lights here, but our view to the north is really covered with trees. I mean, you'd have to go up near the lake for your best views of northern lights. This is a view from the top, the north end of the site, and you can't see the. Oh, okay.
I'll move it back when you're done.
Okay, thank you. Two reclining wooden benches facing south. And it's a nice place to sit at night. And we have guardrails around it now, so you can, they're handrails, you can find your way up and down without falling off the cliff.
It's where the lovers go. That's the lovers.
Yeah,
Lovers spot.
yeah, that's true.
It's called Bob's Bluff.
Mark, you can see the Hubble telescope.
Okay.
Hang on, let me move this back over here. And now you should be able to do that.
Oh, okay. Now, for the telescope use, you can use it, of course, with an eyepiece and your eye right up against the eyepiece and look directly in the telescope. Or you can attach a video camera, or you can attach your DSLR, or I guess you could use a film camera and couple it up. We have attachments for Canon cameras. So if you have a digital Canon camera, you can bring that, or we have a couple up in the case up in the hill, on the hill. I've never used them, but and we do have a small video camera that you can attach to the telescope. That's what I do most of the time. And to start,
I can move that for you.
boy, is that distorted that much? Why does that telescope look 15 feet long?
Because it is.
No, it's not that long. And that's 4.5.
About 80 inches, if I recall.
Yeah.
Focal length. Why is it almost all telescopes seem to end up 80 inches?
2 meter focal length is very popular.
Okay. There's a little closet on the back of the building that this Dobsonian is a 17.5-inch f4.5. And I never looked through it, but they say it has excellent optics. Okay, people agree to that.
I learned to use a telescope on that telescope.
Really?
That was my education.
Where you get the hand truck, unlock it, pull the telescope out, and there's a concrete patch in the deck here, which you go out the back and see it, and that goes clear down in the ground so people can walk around on the deck and not cause the telescope to vibrate.
Are there any eyepieces for it there?
I'm
Are
sorry.
there any eyepieces for it?
We have some in the basement in the eyepiece cabinet. But it hasn't been out, I don't think, for a year. And we have a problem with ladybugs around here. In the fall, they get in. We had one telescope one time, an 8-inch telescope that got full of ladybugs. And then we have a travel telescope for a solar telescope. And it was borrowed by Eric Day maybe a month ago. And he took it home, and the telescope was perfect, but the mount would only run in one direction. So he took it apart and it was full of ladybugs. I don't know how you can, any little tiny hole, you'll find a ladybug parked in for the winter. And yeah, I don't.
Cursor on you. Whenever I move, it goes. Nice. Real good.
Okay. Now this is the biggest observatory we have on the site. It's a big roll off. We have two types of observatories. Ones with a dome, others with the whole roof rolls off on. Domes are very expensive, especially if you get one that's 10 or 12 feet across. But this building runs off on tracks, and all of our roll-offs are motor driven now. You can drive the roof off and bring it back on. They were awfully hard for some people to push off. So they're all motorized. And the front of this building has two doors that drop down, so you can look pretty low into the southern sky. This is a 20-inch F4 Newtonian. There what it looked like inside with the two panels folded down. And this is a very nice telescope. I think, Jim, you were operating it one night. It's the only time I've ever looked through it. Looking at the Veil Nebula in Cygnus. And with just an eyepiece and I think ultra high contrast filter. And I've never seen a deep sky object with that kind of detail. It's just fantastic. But 20 inches that's a lot of light gathering power. So you can get way down to some pretty faint objects. This is not a picture taken from here. I just pulled this off the internet, but we were looking at this part of the Veil Nebula. Now this is remnants of a supernova 8,000 years ago that just exploded and blew all this material off. But just looking at this with this bright star, I'm not sure the bright star was in front or back or embedded in it, but is it? Yeah, but that's a absolutely beautiful.
But it's about 3.5 degrees across, so.
Huge, yeah.
You only see a small part in the reflector, but in a low power refractor, you can fit the whole thing. That's impressive.
Yeah, yeah. This is a view from the big dome, we call it, the Farash Observatory. And then, Bill.
That is me.
That's you. Yeah. You're still with your hands in your pocket, I could tell. And you had a friend joining you, I think, set up on one of the concrete pads we have on top of the hill where you can bring your own equipment, set it up. And there's every one of the pads has 110 volt GFI. So you can plug in your computer, your own telescopes and so on. Here's the 20-inch we showed you first. That's the biggest telescope. Next to it is a 16-inch. This is what we call the cave building because the telescope in it was built by a cave manufacturing company. This was one of the only buildings on the site when I joined. And here is a small dome I'll mention that we have future use for. And here's another dome we'll discuss. God, it looks like it's a 40-foot long telescope. My perspective are awfully long. But this is the cave telescope. It's a 16-inch diameter mirror. It's a Newtonian. And here's, I think that's Doug. Yeah, but there's Doug looking at the sun. He has a filter over the front of it. And it has a German equatorial mount with a drive. So it will track the sun across the sky from sunrise to sunset. And this can be used with a video camera, I'm sure. It doesn't have the best drive on it in the world, but yeah. And of course, it's so high that you have to roll this, a library ladder, I think that you'd call it, around on the floor and climb up it. And this is
That's my
where,
warehouse ladder. That's why I brought it out here.
yeah,
From my warehouse.
from your warehouse. And Bill, this is where the bear, this is where the bear was. Yeah, he's just all clawed up in the back. Yeah, it is kind of strange if you're up here at night and you hear coyotes, even though you know they're probably killing another person down in the woods. You know, it does make your hair stand up on the back of your neck. I've heard coyotes up here quite a few times. So when you come down, if you're a member and you have the combination to the gate to get in, there's nothing wrong with coming in and locking yourself in until you're ready to leave, because they give you, we had people come up before we put the gate down near the door road. We had a chain across way up in the woods here. And you'd come down and there'd be a party that from the night before with beer cans all over the place. It's a good lover's lane. And we've had people park and walk up on us. And if you're up here at night observing and you hear people walking up the driveway, it's just, who, you know. But
Even weirder when they come through on horseback. Have you had some of those?
I've seen horses, but during the day, I don't.
Weird.
Oh, yeah. Well, Max Farash, the guy who donated the 17 acres, he was an avid horseman. He and Dr. Al Yearley, Al Yearley's were riding horses, and they used all the trails up through Mendon and down around here. And when he donated that, I think it was one of his stipulations that it would be always open to the horse riding people. So every now and then you'll see a horse go by. Now this is a dome and the telescope that's in it. They were donated many years ago by the University of Rochester. And it's made out of galvanized steel, and everything inside of it is steel. I don't know how much that thing weighs, but we had a guy, one of the members of the club, know a guy who had a lift on the back of his truck like a crane, and another guy with a flatbed. So it was down here in the back. They loaded it on, carried it up, and placed it on this base that we built. And to get in it, of course, you go up the steps, open the shutters. They open this way. You step through and go down a rolling ladder like we have, I showed you before, and the telescope in. This is a great, this what makes you feel you're in an observatory when you get down in that. You've got the shutters that open like on Mount Wilson or Palomar. And the only thing is, you enter here, climb down the ladder, rotate it around during the night. Of course, it rotates this way following the rotation of the Earth. And if you go to step out, the platform you came in on is over here. Here it's only about a 4-foot drop, but down here, you'll roll till you hit the trees at the bottom. I mean, I've parked in the wrong place a couple times, and you get up and, oh my God, you know, this is. So these are the many hazards of being, dangers involved in being an amateur astronomer, no doubt about it. It's a risky sport. This is oh, I can't. Yeah, you might as well give the rest of this.
No, you do the talk. I'll just move stuff around for you.
My learning curve is pretty shallow in these later years, you know. There you go, put it up here. Now this
Yes.
is a This is a telescope that was donated with the dome. And one of the guys in the club worked, he was one of the supervisors at one of the optical places in the city. They tore it all apart and finished the barrel, painted it, did a beautiful job, cleaned the mirrors. We sent the mirrors into one of the neighbors who works in Ithaca at evaporative metal films, and they put new coatings on the primary and secondary, all free. It was just amazing when you know people. You don't have to know much, you just have to know the right people. And we can open that up, I think, tonight. Just a beautiful thing to stand in that building. Now, equipment for observing at the eyepiece or for deep sky imaging. Now, if you're imaging deep sky, faint, distant galaxies and so on, you want a telescope that has a really good drive on it. As the Earth rotates from west to east, your telescope goes the same speed from west or east to west to compensate for it. And we have a few really nice mounts that do that. Okay. This is, we put this building up in 2005, and we named it after Max Farash, who donated the land. And it has a 12-foot diameter clamshell. Now, this dome is different from the shuttered domes that open this way. The shutters come down, 2 shutters on each side, and you can see the whole sky is open, just like on the roll-offs. That's what's nice about it. Or if it's windy, you could wind from the west. You can keep the west side up and just lower this down and work over here. It's the observing platform is 11 feet above the ground. The pier is concrete, 24-inch concrete that goes down. I think we went down 6 feet with reinforced concrete. The column, the 24-inch column is hooked onto that. And then we have a steel pier at the very top full of sand to keep vibration down. And you can walk around anywhere and not cause any vibration in the dome. This part that sticks out here, that's a warm room. It's insulated from, you want to keep your optics at the same temperature as outside, so you don't have any convection currents changing things around. So your observatory has to be cold. This is a warm room. And we do get a little cold some nights up here. We have 2 electric heaters, and this is insulated. And you can control the movement of the telescope, the focus of the telescope, and control your cameras from a computer down on a bench down here. Pardon?
When we replace the computer,
Yeah, what should I do about that?
Tim Bradley's spoken around.
Oh, he is? Oh, good. Yeah, I think it's ladybugs. I really do. I think it's the computer's full of ladybugs. That's what we're going to find out. Anyway, it's always little things that are breaking down. Pardon? Oh, they're dead ones from last year. Oh, yeah.
You
Yeah.
should see the steps.
Oh, yeah, there are dead bugs everywhere. And this is what we call our brew house. It's a small observatory, but it still has a 12-inch, really nice telescope. This is, once you start using a telescope, you get familiar with a manual control. You want to go to a go-to telescope that's computerized. And this telescope is, the guy, Robert Brewington, built it many years ago. And right after he built it, within a couple of years, he retired, he and his wife, and moved to Phoenix. So we bought it, the club bought it from Brew, and we call it the Brew House. And I'll show you that closer up. The next one is what's up in the tower. And that's a nice place to be too. You've got a great view from up there. It's a 14-inch Schmidt Cassegrain, and it can be operated, 14-inch edge. And it's in a 12-foot diameter clamshell dome. And you can mount the camera up at this point, which will give you a focal ratio of f2. So you can get some very nice short exposures with this. You can also use this with I gotta get a drink. You can also use it with an eyepiece. And the club is on a beautiful AP 1100 astrophysics mount. Great, easy, intuitive to learn. And if you use it down at the Cassegrain focus at this end, you can either operate it at the native focal ratio f11 with a focal reducer f7, or move your camera up at this point and image from up here. And we have, the club owns the camera, the Hyperstar unit, and everything in this building. So that's a nice piece of equipment.
Does the camera replace the secondary mirror?
Yeah, you have to unscrew. Normally, let me go back. On a Cassegrain, Schmidt Cassegrain, there's a corrector glass plate. Light comes in, hits a mirror, comes back up, hits a secondary mirror, and then goes straight through a hole in the primary. So that's why you have such long focal ratios like f11. But you unscrew that secondary, so the light comes in through the corrector plate, off the primary, through a little optical train here to the camera, and it shortens.
It's called a Hyperstar.
Hyperstar, yeah. Here's the inside of the warm room. And this is Dr. Al Yearley. He brought some of his friends down one night to show them the place. Here's the bench. We have the computer down in the far lower right corner. And the door to the tower is further this way, where you open and go up the two-tier set of steps to the up through a trap door to get to the second floor. And this is a pretty amazing when you operate at f2, f1.9 actually. You can see the spiral structure. This is an early picture that it's a stack of 12 90-second exposure, 18-minute total, with no flats, no darks, no guiding. Just take them, stack them up. And what's nice with the computer, you can take those images and just watch the whole thing on the downstairs, come up on the computer screen. So, okay. Okay. The brew house, the small building, is another roll-off.
Keep going, I just move things. There you go, you're good.
Oh, it's this is Gary Opitz playing around with something over there. But this is a 12-inch Schmidt Cassegrain with I think we have a dew shield on it there that makes it look so long. And it's on a forked wedge. But this is really a nice one when you want to go to a go-to telescope. You walk in, turn it on, open the roof, and very simple. It's got one of the nicest control systems of anything I've ever seen. Is the old Meade LX200. Very dependable. It's never failed on. So many of them you get today, you'll go through 2, 3, 4 hand controllers because the electronics are made in a southern part of Bangladesh, I think. At any rate, you go through hand controllers a lot. Pardon? Oh, I mean, they stamp them out so fast. But this is the one you want to move up to as soon as you learn how to use some of the other, like the mead, or like the cave, or the tinsel. Oh, there we go. There was the brew house. There is the brew house. There's the warm room and the clamshell turnaround area up here. This small dome is a 6-foot dome. So I'm getting to the point where I can hardly get in it myself. It's just a very tiny place. It's a little 8-inch Schmidt Cassegrain, and there's a weight limit on it because a big person can't get in there. And it's going to be used, I hope. We have everything we need to make another hydrogen alpha telescope. Because Al Yurley's donated a Eidolon for us with a 0.3 angstrom bandpass, and I'm dying. Yeah, it's a professional unit. Today they're running about 15,000 just for the Eidolon. But we can connect it with a telescope there. We don't have any communication link between here and the solar building, but we just dig a trench and that won't be much of a deal. It'd be nice to be able to control it all from there or from the warm room here. Now we can, at least we were able to, connect the solar building so you can drive the camera, focus the camera, collect your data, all in the warm room. And then it would be the solar building is a small roll off over here. That's where I spend most of my time. The sun is entering a very active period. It goes through an 11-year cycle where it's very active and then it's minimum activity. 11 years later, it hits another maximum. And we really, I think, ahead of schedule because it's supposed to peak, I thought, in 2024. Is that right? And that's during the total eclipse. And I'm hoping Marty has his radio telescope dish. So as the moon goes in front of the sun and blacks out those sunspots, you should see a change in the radio signature as it moves across in front. So I'm dying. I hope it's a clear day. Now I hope Marty has that telescope, but we'll be recording it, excuse me, in our solar building as well at the same time.
There was a question.
Bob,
Which model is CW over the ASI 294 Pro, so it's one-shot color.
Yeah, one-shot color. It doesn't have the resolution that a monochrome camera would have, but boy, one-shot color is sweet, I'll tell you. So that's the solar building. That's where we'll go, I think, next. Yeah. This is this front of the building folds down as well. But we never look at the sun when it's on the horizon in the south because it never goes there. But this is on a Los Vandy mount steel pier, and it has this is 130 millimeters or a 5 millimeter APO refractor, and this is a 100 millimeter double tuned Lunt hydrogen alpha telescope. Now, you were talking about looking at the sun with a green filter and a Lunt Herschel wedge. That's the way to look at the sun. Full aperture if you have a refractor. Full aperture, Herschel wedge with a green filter. And you can, that's for white light observing. I mean, you get absolutely beautiful images of the sunspots and so on. And the surface granulation shows up well too. And this is a fully computerized mount. And Doug and I are down there fighting for it on the weekend. But I'm retired, I can go anytime, I can.
If it's between the fire and, or between him and where the fire is, he'll stop by.
Oh, yeah, oh, yeah.
All you gotta do is set a fire someplace, Bob.
Okay.
Excellent.
Oh, there you go. So this is a sunspot I took back at the, where? 2014. So it wasn't quite at the peak, but this is the kind of imaging you can get of those sunspots and all the detail. Here's this sunspot is breaking in half. You can see the magnetic lines in the penumbra. And this would be a very active sunspot where you imagine some flares to occur, which could cause problems with communications. Those particles hit our atmosphere, or the northern lights. I mean, that's just a beautiful looking sunspot. The uglier are, the prettier they are. Okay, this is the solar spectrum, as you can see pretty much with your naked eye, from about 400 to 700 nanometers. And these are some of the major absorption lines. And you have more than this, of course. But I think we're B at 656 nanometers. That's got to be the hydrogen alpha line. These are the doublet of sodium. And way down here, we have the calcium K, or calcium 2, this called. It's singly ionized calcium. Even though the sun is 70% hydrogen, maybe 25% helium, there are trace elements, iron, an awful lot of other signature element for the elements by looking at their spectrum. And we can look at it in K, which is 393 nanometers, very deep blue. You look in the eyepiece and it drives me crazy. The older you are, the more yellow your cornea becomes, and it filters out blue light. And it's awfully hard for me to see blue. But luckily we have hydrogen alpha up here, up at 656 nanometers. And with our solar telescope up on the hill, double stacked, the theoretical resolution there is 0.5 angstrom. So it's a really nice setup. I borrowed Al Urley's calcium H filter and used it. And I want one really bad. It's a little bit more into the visible, and you can see prominences, and you can see all the detail that you do in the calcium K. And it's only 3 nanometers longer wavelength.
There's another question in the chat. What software do you use to connect the solar building telescope to the computer? Is it?
Well, we were using, before the computer, TeamViewer. And I could, matter of fact, we had an experiment, because bringing a busload of kids down here at night is not a really good idea. The logistics of, it's just the insurance issues and everything else. But if you're looking at the sun during the daytime, we could connect with the local schools and have them move the telescope around the solar surface, focus it, take their images, and send them home and process them at home. And a friend of mine, I had Gary Opitz do that. He's in Gates. We connected by TeamViewer, and he was able to move the solar scope around, focus, and do everything. It really, I think there's a lot of potential in doing that for outreach. Let's see, what else? Now here's what the view looks like. It's in calcium K. This is at 393.4. I think I may have it, nanometers. 393.4 nanometers. And that's the planet Mercury passing in front of the sun, which happens every now and then. And we had a YouTube hookup from the solar building live for the whole 7 hours it took for Mercury to pass in front of the sun. I have no idea how they did it, but you don't need to, you know, people that can.
That video's on our YouTube site.
Pardon?
That video is on our YouTube site.
Oh, it is?
Yeah.
Oh, nice. Oh. Carol Latta has put together a really nice video. She's our historian. And I don't think, is that up on our website?
That's it.
There's a nice video of the buildings from,
Show when you're done.
oh yeah, that's a nice, well done video. And it shows the site before there's a clearing here to, you know, what it is now. Okay. I don't have the touch. Oh, the next one. Now this is what hydrogen alpha, what you can see looking at the transition of a hydrogen atom that's excited from the temperature as it falls into a lower energy state. It gives off this deep red, really nice color. Now, I don't like red. You don't have much detail, but we take the images in black and white at that wavelength, 656 nanometers. Then I make mine, and you see most of them online, they'll be yellow or golden color. That's because you can see the detail better. If that was red, you wouldn't be able to see much. But that's a video image. I think we're taking 500 video frames at a clip, and you can get them in less than a minute. And Doug and I both use the video. And then you put it in a free computer program. It'll sort through all your video frames and pick out the best ones. Say, I want the best 80%. As the atmosphere, and the sun, biggest problem with the sun is you want to look at it before noon. As the earth heats up, you have all of this convection rising, and your image really is bad. But every now and then there's a fleeting second when the image is crisp. So you tell the computer what level you want to save and throw the rest away. It aligns every image, one on top of the other, and then collapses them, stacks them. So now you've got something you can, from video, you can go right into Photoshop with that final image, and they're programmed to help you sharpen, change the contrast, and so on. And Photoshop does a good job with that. I can use Photoshop, but why can't I use this damn computer? Oh.
I can move the slides.
Okay.
Just let me know when you need it.
That's good. Now this is a composite picture. With our camera, Doug would take like a quadrant, and he'd take 500.
These were 200.
Oh, okay, 200 frames of this.
The 4 quadrants in the middle.
4 quadrants and the middle.
And then I did the 4 quadrants again. And
Okay. So what you do is you get the right exposure for the surface. This is hydrogen alpha, deep red. And you get the exposure for this. And then to get the prominences that are like flames coming off the edge, he gets more gain to the camera. And it blows out the solar disk. So then he takes the blown out image and superimposes it with the surface disk, and you get a nice composite seeing all of it. Now I've seen a nice video Doug took, I think every 5 or 10 minutes, and you could see material in these loops moving up and down and falling back to the solar surface as this plasma, which is all charged protons and electrons, rising up, following the magnetic field lines, and then falling back down under the solar surface. Really a nice video. And this is a white light image, again, of this single sunspot. And this is what you get with white light looking through the eyepiece, or without the hydrogen alpha or other filters. That's sunspot active region 3310 on May 26th of this year. And the next one is.
Is that through the Herschel wedge spot?
Huh?
Is that through the Herschel wedge?
Yes, that's with the Herschel wedge, full 5-inch aperture. So you really have to cut the energy down an awful lot. I remember one guy who was a member of the club years ago started doing solar astronomy.
Whoa,
And he used his,
no, I told you Barb gets
Outside moving
suspicious
the
if he's
camera.
playing with a hose in the dark.
and he didn't stop it down or put a filter on it.
I-
And he
Maybe
noticed
when they
that
cut the lawn,
smoke
they cut the
was
lawn
coming
today.
out of the back of the camera. It melted the whole
I bet you.
inside out of it. I guess Galileo, by the time he passed away, he was.
Yeah,
part of
they
the barn
must have, because they
from
cut the
looking
lawn
at the
in
sun
the afternoon.
through a filter that, well, back then, nobody knew anything. So
Yeah.
that's something before you use this kind of setup.
Well,
It doesn't take
I
much.
was
You just
closing
plug
up
it in
shop and I
once
thought,
you
I
learn
looked and
use
it's
the
right next to a
working stuff.
stake. And it was
This is
getting
just
dark, so I
for
couldn't
stuff.
quite tell whether it was a shovel or a
So,
stake.
Doug and I think, are currently the only two using
Okay.
this observatory. And like I said, I can beat him down.
Oh,
here
okay,
during the week,
okay.
that's for sure.
So just in case it rains or
So-
anything, you know?
Okay. The next picture of this sunspot.
Yeah.
Okay.
And
there it
finish
is.
fixing the one that you did the other night.
This is the plasma flowing around in these
I gotcha.
magnetic fields on the sun. It's just amazing. Here's one of those
Yeah.
dark ribbons.
It must have been,
You
it
saw
must have been
off
the
to
lawn
side,
guys.
it
That's the only
becomes
thing I could
like a
think of.
flame. But if you're looking straight down on the brighter solar surface, you see
Hey,
loops.
why not, you know?
This is material traveling
Somebody that actually
upward
gave a shit.
or downward. They can rise up and then collapse. And you can tune
Yeah.
the hydrogen alpha telescope when you're looking
Yeah.
at these things. You should be able to tell if they're coming at you.
All right,
going away,
take care of
or
yourself.
shift in wavelength, red to
Oh,
blue.
take care. Night.
I've never done that. These are extra hot areas around in the plasma. And this is a large filament that's just rising up. I think it's rising up. Maybe I missed it and it's collapsing by now. But always something interesting to look at the sun, on the sun. And you can do it in the daytime and still be home for dinner. You know, it's really nice to be able to do that. Now, this is just recently happened on May 31st. Now, this is from the Solar Dynamics Observatory, which is parked at L2, which is about 1 million miles from Earth, behind the Earth. So it can stare at the sun. It's parked pretty much at L2, but it's got a figure 8 with data received at White Sands Proving Ground. It's pretty much right over White Sands, and another location in Hawaii. And there was this huge flare, and it caused some havoc to ham operators because it disturbed these particles. It was a very bright X-ray flare from, there's a sunspot coming around, right? If you wait another day or two. Yeah. But it's a flaring region, very energetic. And this image is colored blue, but that's what they do, the people that operate the Solar Dynamic Observatory, depending on, and these are extreme ultraviolet. You can't see these with your eye for sure. You wouldn't want to see them with your eye. So they have it's visible from above the Earth's atmosphere, from the Solar Dynamic Observatory. And I check their website every day just to see what's happening. And here's something that's happening. Just waiting to see and have a chance to image the sunspot group when it finally rotates into view. The sun rotates at its equator about 30 days. It doesn't rotate like the Earth, like a solid ball. It's plasma. It differentially rotates. It may rotate 35 days at the poles, longer and longer and longer till you get to the equator.
Did that flare cause the northern lights to come south?
Pardon?
Did that flare cause the more northern light activity on Earth?
Yeah, most of the northern light activity is when you have a coronal mass ejection, they call it. Yeah. But these things, I mean, it's important to know because communication, airlines, people at sea like to have their communication links open all the time. And if you have a coronal mass ejection and you have all these high energy protons coming at the Earth, and you're an astronaut, you don't want to go outside the spacecraft and do any outside work. You want to stay put and wrap yourself in aluminum foil. But so it's very important for the space program to know all of these events that are happening. And what else? Okay, this is in the energy range of 10 million degrees. So this is the radiation, this blue image you see is colorized by the people operating the telescope for different ions. They'll make the sun a different color. So you'll see it green, red, blue. And when you look at them, you'll know what element is being excited. But here, when you get to iron 23, the energy that it takes, well, 10 million degrees to kick. Iron has only 26 protons, so it has 26 electrons. Every one you take off, the next one is harder. The next one is harder. So to take off 23 of them, oh, gee, yeah, you've got some energy there. And this is what it did. The event occurred when the Earth, Hawaii was sort of facing the sun, noon at Hawaii. And this signal here is normal radio, but you can see the increase in radio shortwave reception. It really messed it up bad. So you can, okay, this is from yesterday. This is from spaceweather.com. That's another one we check out every day. And here is that sunspot group that you saw the flare in a couple of days before. And the sun, of course, is rotating in this direction. So you'll see it spread out, hopefully keep growing. Sometimes you'll see a sunspot group and it'll start evaporating. It'll disappear in a few days. But it's really nice when you get a lot of that high energy activity. I'm waiting for another Carrington event. Yeah, many years ago, there was a coronal mass ejection that hit the Earth's atmosphere so bad that the telegraph lines, they said that in the telegraph offices just many years ago, the papers on the desks in the telegraph's office, some of them caught fire. It was and it burns out transformers and everything else. I'm hoping for that, just to have something in my lifetime. This is Dr. Al Urley's. There's a radio dish, 2-meter radio dish that Marty and some RIT students are working on. And this we named, we of course put the name on the door. This observatory was in his backyard in Brighton. He donated it to us. We had disassembled it, moved it down here and stored it for about a year. And then finally built this base and put the pier and so on. He donated the telescope that's still in there and the dome. It's just beautiful piece of equipment. And this is what it looks like on the inside. This is a 12-inch cast grain on a mount that we borrowed from one of our members. And this being set up by Leo Kellett for spectroscopy. And then just got a request from Bob Crumrine, who wants to do some photometry through it. So, yeah.
It's the same optical tube as the one in the brew house.
The same one.
Yeah.
But a heck of a lot better mount. Yeah, that's nice. Here's a few other things that we have. We have this Sky Guider Pro, very small, battery driven. You mount it on a tripod that we have, and you can put your DSLR on there for wide field night photography, or you can put a lightweight telescope on it or a telephoto lens. You can supply your own equipment on this, or I think we loan it too, don't we, Mark?
Somebody's got it right now.
Yeah, that's very nice. Oh, and here's just one of the many loan telescopes that we have in the basement.
What's that?
That's like the one that they use.
Yes, it's same thing, but different manufacturer, same thing. Yeah, it's not just for that. It's perfect.
Okay.
That's nice, Bob. You can take that any place you want. You know what I mean? It's so.
Oh,
portable.
yeah, that's a
You can
nice
go to
thing.
darker skies.
You can take it, put it in your car in the back seat, take it, set it up
On an
anywhere.
airplane.
Okay.
Hiking on a mountain.
And here's a picture that Nick had taken with his setup, which is pretty much like the one I just showed you. You get pretty wide field. Here he had 3 panels that he stitched together. But you can see the entire Milky Way here. It's got to be Sagittarius. You can see Sagittarius star cloud of our own galaxy and how it arcs right overhead. I just love these photos. This is the Milky Way from here.
Yep.
Yeah, that's the big dump.
Early March.
Okay, I'm almost finished. It's at midnight. Okay, I think we want 1, 2, 4. No. Huh. Some site activities planned for 2023 and 2024 is that 2-meter radio dish. Marty and he teaches some students at RIT. Once that's operating for the radio signals, we're going to use that looking at the sun as we're tracking the sun with the solar and watching the radio signature change as it crosses different sunspot groups. Radio Jove, I forgot we even had that. That's in the peak of this building, and it was in the library primarily for Jupiter, which has radio noise associated with it and a couple of its satellites. Again, I mentioned Leo Kellett, Dave Vogel, and now Bob Crumrine with photometry and spectroscopy in the Yearley's Observatory. Get back to some remote telescope operation, solar and lunar planetary via the internet, hyperstar imaging with the hyperstar setup, and other interesting for solar viewing, set up the 8-inch in a small dome with that nice quantum Etalon that we, Daystar filter that we got. Now, I was asked just to mention quickly, observing etiquette. When you're down here during the daytime, it doesn't much matter, unless you bring pets, of course, or if you have a loud radio, that's frowned on. But of course, it's a non-smoking site. If you're down here at night walking around, just feel free to walk up to anybody that's got a telescope that's not obviously taking photographs and ask them what they're looking at, and they'd be more than happy to show you, let you look through the eyepiece. Ask permission to look, don't touch. It's a lot of the stuff is private equipment that's mounted on the pads people bring. I had my telescope down here years ago up on the hill on a tripod, and I walked away from it for 20 minutes, came back, and there were two guys twisting the scope around. And I thought I'd have the big one right there on the hill. But that kind of stuff. Now, laser pointers, people have the green ones, high powered, to trace around, to show people different things in the sky, either an artificial satellite passing over or a different constellation, what it looks like. And they're very handy. But if somebody's taken photographs over periods of time, be careful where and watch you don't point them at anybody. Laptops and laser pointers. Most people bring their laptop, they have a cardboard box or something, they put it in and they face it away from the observing area. Because at night, once you're dark adapted, it takes 15, 20 minutes to readapt for that. And use red flashlights when you're walking around. We have half a dozen in the library hanging on the wall. Don't use don't use anything that's white light, because that'll ruin your night vision for sure. I like this cartoon. I like Gary Larson, period. But here's a bunch of rowdy astrophysicists, tough bunch that monopolized the telescope, and they intimidated all these other guys. You see that all the time. There's an awful lot of rough housing going on with a bunch of astronomers. You know? Just a bunch of crazy people. I mean,
Astronomers are a rough bunch.
oh, they'll drive you. Yeah, you got to be careful around them. Okay. Help wanted, please. You see the lawns, the acreage we have to mow. Now we have a open house. Normally is a work party on Sunday I'll be here at 10 with Roger, and out of here, well, I'll probably stick around and do some, we come down at 10 o'clock and end up at least Doug and I looking at the sun. And that way, that gives the other people a chance to grab the mowers. You're doing astronomy, but God knows you want to get, but they're fun to drive. We have a big zero turn, goes like hell. And we have a nice smaller tractor with a steering wheel and a walk behind, an electric trimmer. And there's an awful lot of little stuff to do. We've got a lot of painting to do. All the wooden trim on the buildings should be scraped down and repainted. And the benefits are great. Unbelievable pay scale. And you can contact Roger anytime, day or night. Just give him a call. And he'll put you on the list. Yeah. So craftsmen or craftswomen of any level, plumbing, electrical, painting, mowing, anything, you're welcome. So please come on out. I think that's my last slide, I hope. Help wanted, yeah, please help us.
Thanks, Bob. Questions for Bob?
Are the sunspots created by, always created by like major flare activity on the sun?
No, the sunspots normally cause the flare activity. The magnetic disturbances, because of the differential rotation of the sun, rotates faster at the equator. Those magnetic field lines can get locked into plasma. It's a strange thing, but as they wrap around and get
Water.
water. Yeah. Thank you. Yes, as they wrap around, they can erupt through the surface. And the sunspots, even though they appear dark, they're very hot. I mean, if, like they said, if you take an electric arc, welding arc in front of the sun, it would look black. The sun is so brilliant. So as that rises up to the surface, that plasma, it gets cooler. It looks a little darker, just like the filaments look dark on the surface. They're very hot.
Actually brings me to my next question. You said that the dark, spots on the sun, are they like cooler areas, still hot, but cooler than the surrounding areas?
Yes, they're slightly cooler. The surface of the sun, the photosphere that you can see just with a pair of filter, just a filter in front of your eye. The white light, we call it, is around 5,000 degrees Kelvin or centigrade, either one. The sunspots could be maybe 1,000 degrees cooler. I don't know how much cooler, but they're fascinating to look at because you can see them breaking up. And if you see a complex group of sunspots come into play or start growing, then you know those magnetic field lines are going to snap together and give off a flare. Yeah, it's really, really something to observe. You look at the sun and you think of the sun, you think of it as just a plain, boring, but Doug and I spend our life at it. Just beautiful. And it's something, and it's dynamic. It's changing all the time. So.
Let me see if there's any questions online here.
Oh, yeah. With an eyepiece. There's a computer in the solar building. Bring your own flash drive if you want to collect the data. Put the camera on, get it focused on the computer screen. Start taking your images, and then it's best to transfer them onto a flash drive and take them home to work them up.
I'm thinking for public.
For public? Yeah, we do in open houses. Yeah, they can see white light and hydrogen alpha. Just walk up and look through the telescope. Yeah, yeah, this. Yeah, a lot of fun. I get so excited. You get some people that get aggressive and you see what happens. It's just terrible.
Just like Gary Larson.
Gary Larson, yeah.
Any other questions for Bob? All right, there's a moon outside, I think.
Ooh.
Really bright moon. Well, thanks, everybody. Glad you guys all came. Welcome to the June meeting. Thanks so much for everybody coming. All right, we're going to sign off online. Thanks for everybody for coming.